Okay, so let's start our lecture today. So, yeah. Let's figure out the next step of the Wedge theory. So, okay, so okay, so he said that the formula sigma z, which is equal to z times the product of w not equal to 0, of 1 minus z over w, e to the z over w plus 1/2 z over w squared is a canonical product representation of sigma z. Okay. So now, he said that how does sigma z change when z is replaced by z plus omega 1 or z plus omega 2. Okay, so from sigma prime of z plus omega 1 over sigma of z plus omega 1, which is equal to sigma prime z over sigma z plus eta 1 it follows at once that sigma of z plus omega 1 is equal to C1 times sigma z times e to the eta 1z with constant. C1. Okay, so okay, so let's see why okay, so yeah, I'm asking why does this relation holds, right? Because I think let me mark this one as the star relation. So let's see. So emphasis of star. So so I think this is true by the periodicity of the zeta function. So yeah, so yeah, so because sigma prime of z plus omega 1 over sigma of z plus omega 1, right? So which is equal to zeta of z plus omega 1 or w1, sorry, I call it, yeah, I used to call it omega, but yeah, I started to call it w right now. So z plus w1, which is equal to yeah, so which is equal to zeta z plus eta 1. Yeah, so which is equal to exactly sigma prime z over sigma z plus omega 1 plus eta 1. Okay. So okay, so let's see why does the relation double star holds. I call it double star, but they just say that what does this relation holds. So oh, okay. Yeah, so okay, so let's try this. So no. yeah, so I'm thinking of yeah, I'm thinking of taking like a line integral so that the left hand side and the right hand side becomes the antiderivative as natural log of sigma prime z plus omega 1 and sigma prime natural log of sigma z plus omega 1 and natural log of sigma z, right? But oh, I think I can do that, right? Because this is an entire function, right? So we just show that it's an entire function. So but this product is only defined at C minus the lattice point. So yeah, I'm not sure whether I can take the line integral using the yeah. So the line integral may not be the antiderivative may not be well defined in this case, right? Because yeah. So so let's see. So no, I cannot take the log, right? If I take the log, shoot. Let's see. So can we multiply by sigma of z plus omega 1 on both sides? So yeah, I think we can do that, right? Because yeah. Yeah, because we are only care about the points away from the lattice point, right? So away from the lattice point, this sigma of z plus omega 1 is always non-zero, right? So I don't need to worry about multiplying by 0 on both sides and then mess things up. So yeah, because this function is only at 0 only when the z is equal to the lattice point and 0, right? And then this theta function is not defined at 0 and the lattice point. So okay, I think I can do that. Okay, so let's just try that. So let's multiply by sigma of z plus omega 1 and sigma z on both sides. Let's see. So multiply sigma of z plus omega 1 and sigma z on both sides of star. So we have so the left hand side becomes sigma prime of z plus omega 1 and times sigma z, which is equal to, for the right hand side, so first I multiply by sigma z, right? I multiply left hand side, I multiply by sigma z plus omega 1. Okay. So the right hand side I'll first multiply by sigma z. So what I get is exactly this one, and then plus sigma z times eta 1, right? And then I multiply by sigma of z plus w1, okay. Okay. So okay. So let's see. So okay, because everything is non-zero, right? So I can do the division. So maybe we can let's see. So maybe we can subtract the sigma of z plus w1. Okay, so let's subtract that and then move everything else into the other side, see what happens. So this implies that, okay, so I'll make the right hand side as the left hand side. So I'll first subtract the sigma of z plus w1, and then that's the product. So times the product sigma prime z plus sigma z times eta 1, right? Which is equal to sigma prime of z plus omega w1 times sigma z. Okay. Okay, so this is true. Sorry, this is a little bit awkward. So maybe I write that. Okay. Okay, so this implies that so sigma of z plus omega 1, so which is equal to, so let's divide everything here. So sigma prime of z plus omega 1 times sigma z, and then the denominator becomes sigma prime z plus sigma z times eta 1. Okay. Okay. So how should I? So let's see. So so can we actually take the log? So let's try. No, it won't help. Maybe we can do the wait. prime multiplied by sigma of z plus omega 1 on both sides, and then multiplied by sigma z. I get that, okay. First I multiply by sigma z, sigma prime z, okay, times sigma z plus eta 1, sigma prime z plus eta 1 times sigma z. Okay. Yeah. So, and then I sigma of z plus omega 1 times sigma prime. Yeah, so sigma prime z omega times sigma z, which is divide. Okay, so this is equal to sigma z times sigma of z plus omega 1 over sigma prime z plus sigma z times eta 1. So let's see about what happened for this term. So wait a minute. Oh shoot. Okay, my bad. So this is sigma prime, right? Okay, so let's check what is sigma prime of z plus omega 1. So wait, why it says false? No, it's not. Okay, so let's no. So this is equal to sigma prime z over sigma z is Okay, so let's write it out to see what happened here. So, oh shoot, I think I need to write out the long expansion formula for the sigma prime. So, sigma prime z. Okay, so this is equal to yeah. So this is like the product, right? E to the z over omega plus 1/2 z over omega squared u over w squared, and then plus so then I take the derivative of z times the okay, I think maybe I'm in the wrong way. So I think the correct way should be trying to take the line integral. Because it seems like the line integral naturally fits the exponential style, right? Because suppose that I can take the line integral, then the line integral. Oh, okay. So, because we have the equality, right? So I can freely take any line integral. Let's use the prime variable zeta. Oh, I think maybe we can use the local exactness of the complex plane, right? So even though it doesn't, yeah. So let me see. Can we actually do that? So, because if we suppose that we can take the integral, right? So then the integral for any gamma, right? So this is equal to the line integral of any gamma of sigma prime z over sigma z plus eta 1. Let's use the variable zeta, d zeta. So suppose that this is equal to sigma of yeah. So what does the hand sign equal to? What letter should I use? Yeah, suppose that there is some log. Okay, so suppose that there is some log that this one is equal to the log of this sigma of z sigma of z plus omega 1. Okay, so let's suppose that this is true, and then yeah, so we have the right hand side as another log, right? Of sigma z plus eta 1 z. Shoot. Oh yeah. Log of sigma z, okay, plus okay, and we do it separately, okay. and then we take the exponentials, right? Plus some term c1, okay. That'll be exactly this form, but the question is that what is the theorem behind this one? Okay, so let's see. So whether I have time right now. Okay, so I'll try to come to next time to see whether we can figure out the theory that allows us that's better insight. Okay.